Hello, hello. Welcome everyone to another day of daily LeetCode live streams here on Monday, August 22nd. Starting off the week strong with our daily live stream, 5 p.m. Eastern Time. A couple of housekeeping tips. So if you're interested in knowing which of the questions that I've done so far I consider top quality questions, make sure to visit my website at www.raphaelslist.com. And on there you can see all the questions that I consider top quality questions. You can click on each one of the individual stream clips to be taken to a YouTube video where I actually talk about that question. So it gives you a chance to actually look into my thoughts as I'm completing one of these questions. You're also linked to the LeetCode question itself, and you're given this list of topics in case you need a little bit of a hint. One of the cool things is you can actually keep track of your progress just by ticking off these green check boxes here, and you can see this progress bar being filled in on the top left. So if that's something you're interested in doing, make sure to visit this website. You can keep track of your progress. I know it's going to help you remain accountable and progress in your journey. If you like doing LeetCode, if you like watching someone try and come up with optimized algorithms while doing these questions, make sure to subscribe to me on YouTube, follow me on Twitch, and if you're feeling really good, make sure to ring that notification bell so you'll always be kept up to date when I come out with a new episode. So without further ado, yesterday we left off on page 3. We're still tackling page 3. Currently sitting at 191 questions, so pretty amazing. Very happy about that. 9 questions away from 200. I know this week we'll get there, so that's going to be a very big milestone for us all. So let's go ahead and continue where we left off from yesterday. So let's start right here at mean. Let's see, mean of array after removing some elements. Okay, so given an integer array, ARR, return the mean of the remaining integers after removing the smallest 5% and the largest 5% of the elements. So, I mean, one way that I can think about doing this is already thinking, let's see, 5% of the elements and largest 5% of the elements, and then the mean of the remaining integers. So after erasing the minimum and the maximum value of this array, all elements are equal to 2, so the mean is 2. So I think we can kind of just do this in 3 different steps, or a couple different steps, right? What I'm thinking about doing is, 1, we can sort our input array from smallest to largest. Then, let's see, we need to figure out 5% of what? Like if we had, let's say we had like 10, right? Well, is 10 a good number? Because 5 is what, a 25% of the elements, and the smallest 10% of the elements. So what does that actually equate to? If it's like 10, like what's 5% of 10? I'm like really bad at this, obviously. 5% of 10, is that whatever I can? Is it just 0.5? So this is just, if I divide the whole thing by 5%, that's going to give me the thing. Let me see. Let me just make sure. Obviously, my math is not the best, but let's see. That's 20. But if I do times 0.5, that's just 5. Okay. After erasing the minimum and the maximum values of the array, because let's just say we sort it, right? If we already have our sorted array to begin with, so we'll have const sorted r.sort a minus b, return the mean of the remaining integers after removing the smallest 5% and the largest 5% of the elements. What is oh man, what is 5% of a number? Like, how do I figure that out? Why 1/2 of 10%, 5%, so we divide 10, simply divide 10% of the number by 2. Okay, divide 10% of the number times, or what is it? Divide 10% of the number by 2. So here this is 1, 2, 3, 4. Well, I guess we can do 10% and then by 2 is 0.5. So what does 0.5 even equate to though? What's the length of this? It's going to be at least 20 divided by 10 divided by 1. So we remove 1 from each. Okay. So what's the length? What's the length that we have to do? Or items removed will be equal to math.floor of r.length divided by 2, r.length divided by 2. And actually I want to do math.floor of r.length divided by 2. And then I think we should just do another divided by 2 there, right? Or is it divided by 10? Is that what they said? Simply divide 10% of the number by 2. 20 divided by... This is literally a math question that is tripping me up here. 10% of 20 is 2. Right? Yes. And we got there by doing what? 20 divided by 10. Yeah. r.length divided by 10. And then this divided by math. Maybe we should just do, I don't know, 10%. 10% is math.floor of r.length. And const, what did I call the other one? This is items removed, or removed items, equals math.floor of 10% divided by 2. That's 5%. Okay, cool. So what if we just now, let's see, the mean, we can just add all these up by the amount. I can start from, could I do something like, say this is let. What if we had removed items? Removed items is less than, let's see, r, maybe sorted.length minus removed items. I think we also have to do -1 here. Removed items plus plus. Let sum equals 0. Can I just be tallying up numbers here as I go along? Sum plus or equals sorted at removed items. This is a terrible name for an index, but bear with me. We'll figure this out as we go along. And what is that distance now? It's going to be, is it just divided by return math.floor of sum divided by, let's see. Now this is actually going to be all wrong, right? Because I'm changing removed items inside of my array in here, inside of this for loop, so that's not good. What is it that I'm trying to do, right? I essentially want to get this range, add up all these numbers, and just divide it by the amount of numbers in that range. Here, is it the same thing here? So we can do, like if this is 1, I want to do removed items.length minus, I guess I can do -1 here. So instead here, maybe I should create I. Let I equals removed items. Let's just say that, right? I less than sorted length minus removed items. I plus plus. Sum plus or equals sorted of I. And now can I just divide that sum by this range? Removed items -1. And what would that be? Like, how do I can just do sorted length minus removed items. That'll give me something over here. How, and then what, do we just add? Or do we just remove one from either side? I guess we can also do that. We can just remove 10%, right? Would it just be sorted dot length minus 10%? Something like this, 10%. I know this is weird. I'm just gonna run this real quick and see what that gives me. Okay. Honestly, I wasn't expecting that, but let's see. 2, 4, 4.7. Okay, so they don't want me to do math.floor here. Two, 4, 4, 7, 7, 8. Let's submit this. Cool. Yeah, I mean, I'm game for that. Yeah, so what is it that I tried to do, right? I mean, I kind of like completely didn't even go with my plan, and once I started coding, I just went for it. What I did was, what we want to do is we have this whole array. I think the easiest thing to do is just sort it, because that way we know we don't have to worry about lowest or smallest. By sorting it, we already get that for free. And then what I do is I figure out how many items equal, like what amount of items equal 5%. So I take 10% of it, and then maybe this, instead of removed items, this should just be 5%, right? I equals 5%. So that's like, I'm starting at the 5% mark. Let's say it's like 1, right? And I'm going all the way up until sorted length minus the 5%. In this case, just this one, right? So I just want to consider these numbers inside of here. Rather, these numbers inside of here. So I create a sum. I go through all these, I calculate that sum, and then I essentially just do divided by sorted length minus 10%. You want to divide it by the 90% of items that are there, right? So yeah, it seems pretty straightforward to me. Our bottleneck here is going to be O of n log n for the sorting, because we're using quicksort here. And then as far as space complexity goes, it's going to be constant. We're not really creating any extra space, right? No space needed for the input size. So I think we're good on that. Let me double check. Oh, I don't even think I have access to my stream. Let me just double check to make sure everything sounds good. Come over here. Are we good? Okay, cool. Yeah, I think we're good. We're good. I don't know why I sound so low. Okay, that's because my audio was low. Okay, sweet. So let's go to the next one. Check if a word occurs as a prefix of any word in a sentence. So given a sentence that consists of some words separated by a single space and a search word, check if search word is a prefix of any word in sentence. Return the index of the word in sentence, or search word is a prefix of this word. If search word is a prefix of more than one word, return the index of the first word. Okay, so I mean I think here we just return the first one. What I mean by that is we just return the first instance where we find the search word, else we just don't return anything. Or rather, we just return that -1. So Berg, here we have problem. Second and sixth word. So as soon as we find it, then we just, yeah. Now, I mean, there's like an easy way to do this, and I don't see why I wouldn't want to take that approach. I'm thinking of like, I have the slice length of each one of these for every single word. I can just slice and I can see if it equals that, and if it does, I just return the index. That's what I'm thinking. Let's see. I could also split it. If I split it though, that's going to be a linear time operation. I can split it by space, but maybe instead of doing that, I can just keep a pointer that goes to the entire word, or rather the entire sentence. Anytime I come up to a new word, then we're good. And how do I know I'm coming up to a new word? Well, I is either going to be 0 or the previous thing will be a space. Only in those two cases, right? And can we assume lowercase English letters and spaces, prefix, index of the first word? If there is no such word, return -1. Can we assume that we have single spaces? It doesn't say so, but let's try that out. I think that's fine. So let's do this. Let's say let word index equals 0. For let I equals 0, I less than sentence dot length I plus plus. So here, what I'm actually going to do, oh, I guess I can just return, yeah. So here I can say if I is equal to 0, or sentence of I minus 1 is equal to a space, right? That means that currently we're on a new word. So what can we do? If, so we can say if the sentence that we're currently at right now. So let's do this. Let's say, well, I guess we can say if sentence, How is it that I want to do this? I want to slice, yeah, if sentence dot slice from I to I plus search word dot length, sentence dot slice, if that's equal to search word, then we return, let's see, if I here I can say word index plus plus return word index. But down here we just return -1. Let me explain myself here and show you what I'm trying to do. So let's say here we have I love eating burger. So we have I, so I is equal to 0, which means that we're currently on a new word. Now we try and slice it, right? We slice from the current I all the way up to I plus the length of search word, which is burg. So we go up like 4, right? Let's say like up to here, or maybe up to here. This is not equal to the search word, right? But we do increase word index because if this were true, we would return 1. But now we just keep going, right? We get to the end of this. This isn't true, so now we just keep going. Not equal to 0, and the previous one's not a space. Now here, it's not equal to 0, but the previous one is a space. Now we increase the word index. We do slice again, and we kind of just keep going from there, right? At the end, we're going to come over here. If that's still the case, we'll just end it, and then we'll just return -1. So I'm feeling pretty good about this one. Oh, wait, does it want me to return? Yeah, it wanted me to return word index. (4,2, -1, 4,2, -1). Let's return this here. 57.46. I'm pretty happy with this. I think like if you know, there's a lot of questions that are like this. Something that we could have done is we could have split the word by space, but that in and of itself is going to be a linear time operation, and then having to go through each one of those words is going to be another linear time operation. Here we're doing it in a single pass. We don't have to split it and then go through the array of split tokens, right? We're just doing it in a single pass. So I feel like this is a pretty effective way of doing this. Let's keep going here and see what we're getting. Yeah, some of them run really slow, some of them run really fast. I'm very curious about discussions. C++, add a leading space. We add a leading space to our sentence and word, then we can do a string search and see out the number of spaces before the found word. I guess. Optimize KMP-ish solution. We can use 2 pointers to solve this problem in a single pass. Okay, we just need to do one check. If word count plus else, return size. Well, just check the previous character as a space. Here we do not need the KMP check, as space will restart J naturally. If word count plus or equals space. I'm not sure what is happening here. This is crazy. Straightforward codes. Okay, sentence split. That's the split method. If words at I-1 starts with search word, return I. Oh, but see, both of these are being split, which I don't mind. I mean, I'm not completely opposed to that, but oh, wrong thing. Okay. Let's run this again. 44.20. Yeah, I'm good with this. Let's go ahead and continue. Count integers with an even digit sum. Make sure we got, oh, I think you guys probably heard that. All right, given a positive integer num, return the number of positive integers less than or equal to num whose digit sums are even. Okay, I know for sure that based on this, the answer is not going to be probably as easy as we think. But let's think about this. We have 1,000. All right, given a positive integer num, return the number of positive integers less than or equal to num whose digit sums are even. And I mean, how much less does it want me to go? To, I guess, up until 1. So, I mean, in each one of these, right, and every single, if we think about, we have like 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Like, for every single Like if it's 4, what do we just have? Oh, 4 and 2. Okay, if it's 8 or if it's 9, what do we have? There might be a way, or actually wait, if it's even, I think there's definitely going to be like a pattern here. If it's odd, then we can just like subtract 1, and how many times, is it just how many times does 2 go into, does that mean there's 7? Like 1, 2, 3, 4, 5, 6, 7. It might just be that. I'm very curious, like return num modulo 2. If it's already odd, do we just return num modulo 2? Else num minus 1 modulo 2? (402). Okay, wait. Num. So return num modulo 2 is equal to 0. Yes. Oh, I think I should just do divided by 2. Two and 2, about 30. So that'll be 15 times. Ooh, 14. Why though? 2, 4, 6, 8. Oh, whose digit sums. Oh man, that completely messes it up. That completely messes it up. Man, and we thought we were close. Digit sums are even. 1, 3, 1, 5, 1, 7, 19, and 20. Yeah, that messes it up. Because there's an n log n solution, right? For every single number underneath this, we just do the trick where we pick off individual digits. We calculate them and we come up with that. But there's going to be, I think we're looking for a pattern here. 1, 3, 5, 7, 9, 2, 4, 6, 28. It's one of those things where there's a pattern for sure. Do we want to do the pattern? Digit sums are even. Let's see. We can also just do let even equal 0 for let I equals num. But let's just go from let I equals to I less than or equal to num. I plus plus. Let's see, we can say let digit equals I, while digit, it's not even that, right? We need to add each individual. Yeah, let's say digit sum equals 0, while digit, we can say digit sum plus or equals digit modulo 10, and then digit equals math.floor of digit divided by 10. If digit sum modulo 2 is equal to 0, even plus plus, and then we come down here and we say digit sum equals 0 to reset it for the next one, return even. Right, no, that's probably it, right? That's the pattern. Notice how all, oh, let me remove that chat box a little bit lower here. Let's get this going right here. Nice. Okay, nice. Notice how 2 through 8, 2 to 8, all numbers are even. 11 through 19, all numbers are odd. 22 to 28, all numbers are even. So is it just however many starting, like, if we have a 4, like I sort of understand what you're saying, but then how do we figure out how many numbers? Well, is it always the same actually? Is it always like 11, 13, 15, 17, 19? 28. Let me see, does 30, like when we come off the 8, so is it going to be 31, 33, 35, 37, 39? Yeah, right? I guess it's always going to be the same pattern. So the even ones, they'll always be 4. The odd ones, they'll always be 5. So if we're an even, like if we're in an even right now, let's think about that. I think I get what you mean now. Now, how can I associate each one of these? If I'm looking at an even number, oh, maybe it could be that if it's 4, it's clean, but maybe if it's, wait a second, I'm gonna try something crazy, because maybe this thing can still, maybe this can still work. Maybe it should just be num divided by 2 minus 1, just to account for num divided by 2 minus 1. I wonder if that will work. 32 and 15, 2 and 14, and that's because it's 30, but we're not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If num divided by 2 is 0, oh, both of these are 0, but why in this one? (40, 48) will be 40, 42, 44, 46, 48. Right, no, I get that. Like, I get that piece. But how is it? Is it just like, how many of those groups can I fit into that number? Count integers with even digit sum. I can fit like 1 group, 2 groups, 3 groups, maybe. I mean, this is 4, 5, 4, 14. It will always be 5 numbers after 10. It will always be 5 numbers after 10. 0 through 10 is 4 numbers. 10 to 20 is 5 numbers. 20 to 30 is 5 numbers. Really? So wait, you're telling me if num is less than 10, if num less than 10, we return, no, wait, it's always going to be 5. So if num is 30, you just have to do 4 plus 5 plus 5. Oh, I see what you're saying. But like, yeah, it makes sense when you put it in paper, but I'm having trouble putting that into code. Like, how many times do I add that 5? Is it per every 10? Like, if it's like 20, do I just do, like, I add the 4 once and then I add the 5 for however many times 10 goes into the number after that? 4 divided by 2. Like, I see that pattern, but if I pick any arbitrary number like 26, like 26 won't be 4 plus 5 plus 5, right? This one's so tricky. Or maybe I'm just not taking the time to like really draw this out and think about it. Given a positive integer num, return the number of positive integers less than or equal to num whose digit sums are even. I know we're close here. I think I'm gonna come back to this one later. I think, like, I get that pattern, but my brain right now is just not working for the math. And it probably is very simple math, but like, I guess this works nicely if it's just like a number in the tens place. But maybe if it's like any other arbitrary number, like I'm trying to figure out the positioning of it or like what type of data structure I need to figure out. I'd like, let's see if like maybe the last 10 minutes, I'm going to leave this tab open to see if we can come back to it. Let's try this one. Oh, crawler log folder. The LeetCode file system keeps a log each time some user performs a change folder operation. The operations are described below. Move to the parent folder of the current folder, okay? Remain in the same folder and move to the child folder named X. This folder is guaranteed to always exist. So we're given a list of strings, logs, where logs of I is the operation performed by the user at the ith step. The file system starts in the main folder, then the operations and logs are performed. Return the minimum number of operations needed to go back to the main folder after the change folder operations. Whoa. So D1, we're in main, go to D1, go to D2, then back to D1. Then we go to, oh, D21, okay. Move to the child, remain in the same, and remain in the same. Use this change folder operation to go back to the main folder. I feel like I just want to take, I feel like I want to keep track of my depth. Maybe anytime I see, there's like 3 operations here, I think. There's a couple, like if I just keep track of my current depth, that's going to be the minimum amount of operations I need to do, right? But does it change with depth? Can I go here? This will be like 1, 2, 2, 3, 2, 3, output 3. Now from here, what do we do? Because we just go in the, we go in a child, then we go up, we go up, we go up. Is this like not valid once? Maybe if I'm already at 0, if I do any of these, I can't go back. I think we can solve this. Like I was almost thinking about using a stack, but yeah, let's go through each. Let's say our depth currently equals 0 for const log of logs. Right, like when do I want to? Yeah, for me, there's a couple of different cases here. So if log is equal to this, else if log is equal to X. Oh, but move to the child folder named X. This folder is guaranteed. How can I make sure that it's not remain in the same folder, move to child folder, and it's just going to be X. So I want it to be like any pattern like this. Okay, if log is this string exactly, else if log of 0 is not equal to a period, I guess we can just look for, right, because like this will catch any log that is the parent, this will catch any log that's in this form, right? Because if it was this one, it would just stay the same. Can I just depth plus plus, depth minus minus? Is this, am I being like way too naive here? Am I being way too naive here? No, wait, yeah. Then I go depth minus minus. Oh no, this should be depth minus minus. This should be depth plus plus. Because like, I mean, let's say we go through here, right? Let's say we use this one and L represents our log. So here depth is 0. Is log equal to the parent one? No. If log is not equal to this one, we go depth plus 1, right? So that means we're one deeper. Now we go to the next one. It's not equal to the parent. Else if log of 0 is not equal to period, yep, so we go to another depth. Now it's equal to parent. If log equals the parent, we do depth minus minus. We should also say if log not equal to 0 and depth is not equal to 0. All right, now we go over here, we go depth plus plus. Right, so we went minus to 1, now we went to 2. Now we come over here, it's not equal to parent, and it's in the period, so we don't do anything, we stay in the same place, and that's how far down we've gone. So then we just return the depth that we're currently at. Return depth. I feel like this might be too... Logs I contains lowercase English letters, digits, period, and... Is there ever a case where... Well, I feel like this might be naive. Depth plus plus... Oh, I removed... 2 and 2. 230, 230. Let's see. We're just gonna go for it. Submit it. Okay, wow. Yeah, I don't know. For some reason, I thought that was gonna be like more tricky, but I guess not. Yeah, sometimes it's weird. Like sometimes I'll be working on a question and I'm thinking like, man, is it really just gonna be this? And sometimes that can actually, like if you're not confident with your answer, if you're not confident with the direction you're going in, it can actually lead you down another path. Right? So I mean, this is just linear. We're gonna go through every single log once and that's gonna give us our answer. I'm gonna be very curious to see if there's a different O of n loop. Res, continue, else, res plus plus, right? Okay, cool. Oh, this is nice. I like this. Instead of checking specifically, instead of like specifically preventing it, we can just do this. Yeah, that's a nice little pattern. I like that. Cool. We've done 3 questions already. That's nice. I know I removed the count integers one off, but I'll remember to get onto that. I'll remember to get to that one at the end. You're given a 0 index integer array nums and 2 integers key and k. A k-distant index is an index I of nums for which there exists at least one index j, that I minus j is less than or equal to k, and nums of j equals key. Return a list of all k-distant indices sorted in increasing order. Okay, let me see the example here. So 3491395, key is 9 and k is 1. Here, nums at 2 equals key, and nums 5 is equal to key. So it says a k-distant index is an index I of nums for which there exists at least one index j, such that I minus j, what? K-distant index, one index j such that a minus j is less than or equal to k. Okay. For index 0, 0 minus 2 is greater than k. And nums of j equals key. Okay, so let me try and figure this out. Like, really the first thing we need to do, whatever this answer is, we need to find all the places where nums of j is equal to key. Right, and key is 9. And we have that twice. We have one in index 2, right? Nums of 2, 3, 4, 5, and 5. Now, okay, so at least one index j. Okay, so now with 2 and 5, less than or equal to, okay, so it's 0, 0 minus 2 and 0 minus 5, 1 minus 2, okay, for index 2, k-distant index 3 is less than or equal to k. What happened to the other one though? For index 0 is greater than k, so there's no j. And this is index I minus index of j. 0 minus 2 is less than or equal to k. Zero minus 2 is greater than k? Wait, what? For index 0, 0 minus 2, oh, the absolute value. 2 is greater than k, and 5 is greater than k. There's nowhere, and nums j, thus 0 is not a k-distant index. For index 1, okay, so 1 is a k-distant index. Sorted in increasing order. I think what we can do here, this one's interesting. Again, when I see that they want the answer to be output in increasing order, I think about creating an array of size 1,000 and sort of putting our answer in there. Now, how do I want to do this exactly? Because this, for index 1, and nums2 is equal to key, so 1 is a k-distant index. So do we just try it for all of them? That's the part that's going to be kind of like potentially it could take, like, the time complexity of this could potentially be O of n, like, cubed or something. Not cubed, squared, n squared. Because for every single one of these indexes, we're going to need to try it with everything inside of there. However, maybe not, though. A k-distant index is an index I of nums for which there exists at least one index j. 0 minus 2 and 0 minus 5. And then we do 1 minus 2, 1 minus 5, 2 minus 2, 2 minus 5. We do that for every single one. I can certainly think of like a brute force way of doing this. Do I want to start that way though? Two is a k-distant index. Right, because like I could do it super brute force and for every single index compare it with all the keys that we find. And then at the end, we just sort the output. It's really, really not efficient at all. Now, as long as one of those is true, is that fine? There exists at least one index I. Oh, so we only need that to be true for one of them. And as soon as that's true, we can break out of that inner loop. For nums j equals key. Okay, let's see. Let's create key indices for const n of nums if n is equal to key. No, I want to actually do this style of loop. I less than nums dot length I plus plus. If nums of I is equal to key, then I'll say key indices dot push I. Now what we can do is we can say const result for let I again equals 0, I less than nums dot length I plus plus. Now for each one of these, again, really not like amazing. We're gonna say for let j equals 0, j less than key indices. Or I wonder, no, because I'm gonna have to do this for all of them, right? J less than key indices dot length j plus plus. So what are we gonna say here? We're gonna say 0 minus 2. We're gonna go through every single one. So what is this one doing now? So here we say if, let's see, 0 minus 2. These are the indices, right? So if math.abs of I minus key indices of j greater than k, and they want it to be equals key, actually is less than or equal to key. Okay, less than or equal to k, we can say result dot push I, and then we'll just break out of this loop and immediately return to the next one. And then here we can say result dot sort a b a minus b. We're just sorting the output at the end. Personally, I'm not in love with this. Let's see what the answer is though. 1 2 3 4 5 6. Okay. Well, that one can be tricky. 0 1 2 3 4 0 1 2 3 4. Let's submit this. 91 point. So yeah, I mean, It seems fast, but you develop like code smells after doing this for a while, and I truly don't think this is the way to go. What we could do, what I want to do is instead of having to sort this at the end, I wonder, let me see, 0, 1, 2, 3, 4. What I could do, I can say const result is a new array of 1001. And then what I can do at that index, like result of I can fill this. I can fill this with 0. And then here I can say result of I dot, or just result of I equals 1. Let's just say result of I equals 1. Okay. And then what I can do here, const result, let's say this is our k distant indices, Instead of result, we'll do this, k distant indices. And now here I can create result, and I can say for let I equals 0, I less than k distant indices dot length I plus plus. If k distant indices of I is equal to 1, result dot push I, return result. So we should get the same here, right? Okay. Okay, cool. So one thing that we did here, and this is a very common theme in LeetCode, I see it all the time. Instead of sorting, and why does this work? This works because, one, I know that my space will be bound by 1000. Like this upper bound is reasonable enough that creating an array of size 1001, that's okay. It's constant space. Okay, it's always going to be, well, at least this piece is constant space. But because this is in order, right, going from 0 to length 1000, that means that all the k distant indices will already be in order, in increasing order. We don't have to sort it anymore. So that removes the n log n, which really that would have been our bottleneck. If we do, let's see, if we go through all this, let's see, nums.length, this is like O of n, let's say. This is also another O of n. However, this piece, I don't love this piece. This is definitely another bottleneck that we should be able to get rid of. Now how? I don't know. Find all k distant indices in an array. There might be some other optimizations that we can make here. -2. What's a really efficient way of finding, instead of having to go through all the key indices? Would it actually help if we only went, because like theoretically, right, wouldn't it actually make more sense like if we do, no, I was gonna say, okay, no, that's fine. I was almost gonna reverse this, so like, but it's gonna end up being the same. I was gonna say like let's go like key indices will probably be smaller than the length of num, so maybe I should only be looping through the key indices and figuring out based on these which one of those conditions is true, but it's still going to be the same, right? It's going to be nums.length times key indices.length, or key indices.length times nums.length. That's going to be the same math. That's like one thing I thought that we can do. Let's maybe make that a little better. See what discussions have to say. Got one pass. We can use 2 pointers to swipe the array once and collect all k distant indices. Some explanation will be better. You need to return the k element indices around the key wherever it is found, and be careful with overlapping ranges. Key is 9, k is 1. So we return 1, 2, 3, Oh, and including that one too? Really? So for j equals max of, okay, up until plus plus j res dot pushback. Interesting. So it's like that k distant indices. I think I'm not saying this to make it seem like, oh, it's like, it's not that. I just don't think I understood the question well enough to be able to think of that. But that does make sense. The k index thing kind of messed me up. I didn't realize it was just like literally wherever 9 is, we just want to find everything that's 1 away from 9. Right? So that's what we do. That makes sense. Obviously, everything makes sense once you read the solution, right? That's pretty cool. Okay. Let's see. Find all k indices, min-max game. You're given a 0 index integer array nums whose length is a power of 2. Apply the following algorithm on nums. Let n be the length of nums. If n equals 1, end the process. Otherwise, create a new 0 index integer, new nums of length n minus 2, n divided by 2. For every even index, okay. Min-max, min-max. Oh, this is like classic. This looks like classic recursion here. For every even index I, assign the value of new nums I equals, okay, min-max, min-max, min-max. There's definitely a nice way to do this recursively. Yeah, like our base case, base case is when nums is equal to 1. Nums.length is equal to 1. So I think here we can say if nums.length is equal to 1, we can return nums. Min of 1. 3 is already the last remaining number, so we return 3. And now what we have to do is we have to sort of calculate 0, 1. So at every even index, 0, 2. For every odd index I, assign the value of new nums I as max of, replace the array nums with new nums. Max, min, max. What would be a nice way for me to do this? What I want to do is, I want to know at every step 0, 1, 2, 4, 6. It'd be nice if I had, I could have a toggle or something. 0, 1, 0, or 2, 3. Min, max, min, max. We always start with min. Let's see, let min equals true. We can say new nums equals 0. Now we can just sort of go through this. For let I equals 0, I less than new nums dot length minus 1. I plus or equals 2. So if min, then we can say new nums dot push math dot min of nums of I or nums of I plus 1. And then we'll say min equals not min, else new nums. We'll just do the same thing again, right? New nums. Now we'll just push the max, and this we can remove because it's always going to be the same for both. So we can say min equals not min. So let's go over this real quick. If we have this, and we have our I, right? And let's say we have new nums. We start off with min equals true. So we say if min unums.push math.min of nums of I, or I plus 1, so that's 1. We go over by 2. And now if min, no, so we do the next one, math.max, we push the 5, go up by 2, toggle it, it's true again, push the 4, toggle it, it's false again, push the min, okay, and then we just return. Why at the end we should just return min max game, return min max game of new nums. Will this work? Nums.length equals 1. Oh, can we get to a case where, yeah, probably. Are we always going to end with the last number? Okay, so return if nums.length. Oh, wait, can we be given? No, okay. Unums.length minus, oh, this should be nums. Unums.push nums of I plus or equals 2, 1 and 1. Let's see if this one, oh, this is just going to be 3 because we should immediately return. Oh, 1 and 3, 1 and 3. Okay, submit this. Sweet. Yeah, it's like there's absolutely, like I mean, this is with anyone, right? I'm definitely better at some things than I am at others when it comes to these algorithms. Like these recursion problems, I don't know, I just feel good about them. But then like this one we tried to do earlier with count integers with even digit sum, like seems easy enough, but I just can't like wrap my head around the math. Let's see if I can maybe make this a little bit more, I mean, really for no reason, just for fun. This is really just like, let's do that. Like, there's no need for that, you know? We're barely even saving space. Unums.push, math.min, math.max. Unums.push. I mean, we can even come up with, we can sort of abstract this. Unums.push. No, because then, yeah, that's fine. That's fine. I'm good with this. I think that's fine. I mean, this didn't really do anything. It probably made it harder to read. 57.92. This seems like a classic recursive question to me, and I'm happy with this solution. Let's see what discussions have to say. Recursive, straightforward solution. Even this looks a little bit more complicated, I think, but about the same. It's pretty much the same. Oh, 1 space, 3 lines. Yeah, I guess you can probably do it like this, but is this readable? I mean, can anyone, I'm sure if I spent enough time going through this, like I would understand it, but it's just difficult to understand. I think the recursive one's a little bit more simple. Let's spend some time doing this one because we're already over the hour. I normally like keeping these to an hour because for people that are getting into the videos for the first time, I want to make it as easy as it is as I can for them to remain like on a schedule. So count even. Given a positive integer num, return the number of positive integers less than or equal to num whose digit sums are even. So like we definitely have that range, 2, 4, 6, 8, and then after 10 they always have 22, 24, 26, 28, then we get to 30, 32, 34, 22, and then 28, and then 30, no, but 30, 31, 33, 35, 37, 39, 40, 42, 44. Yeah. Why is this one so difficult? I almost feel like, I think the answer can just be, if it's less than 10, we can just divide it by 2. If it's more than 10, we just divide it by 2 and subtract 1. Right? So like with that, would this be 9? Like 3, 6. You see, but that's actually 10. 14 integers less than or equal to 30 whose digit sums even. Like if it was 20, right? It'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's because it's even. Maybe there's like multiple cases here. What happens if it's even and less than 10, or maybe less than or equal to 10? That's 2, 4, 6, 8, 10. Okay, even and less than or equal to 10. Even and greater than 10. Odd and less than or equal to 10. Odd and greater than 10. What would that be? Like in this case, if it's even and less than or equal to 10, if it's 10, it's just 5, right? Because 2, 4, 6, 8, 10, that's 5. So I think here we can do n divided by 2. If it's even and greater than 10, like here, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that also the same? Is it just n divided by 2? If it's even and greater than 10, like if it's 14, 1, 2, 3, 4, 5, 6, 7. See, but no, 14 is not divisible. Yeah, it's not divisible. Like the digit sums are not divisible. It's almost like we have to figure out what group it belongs to. I'm wondering if I should just do this like the easier way to at least say that we completed it. You know, no, I'm not going to do that. Let's end it here, and then we'll come back to this on like a weekly roundup or another day, because I think it's easy to figure out the solution. Like we already did it once, and I kind of like I regret removing my answer, but it's fine. All we have to do is go from 2, or actually 1, all the way up until the number, and for each one of those numbers we can figure out if the addition of its individual digits are even, right? And we can do it with the trick that we do the modulo and the division. That would be an n log n solution, but I'm sure we can do better, probably constant time. That's what I'm thinking. But since we're over the hour and I want to keep it condensed for everyone, I'll end it off here. Let's see how well we did today. We were at 191. I think we did like 4 questions. Oh, 196. We did 5 questions. Only 4 questions away from our 200 question mark. So once again, thank you all so much for watching. If you like what you saw today, if you want to keep doing these with me, make sure you subscribe to me on my YouTube channel, follow me on Twitch. You can even ring that notification bell on YouTube. It's going to help me continue making these videos, and it'll keep you updated whenever I come out with new videos. And of course, if you want to look at all the different questions that we've done so far, you can go ahead and visit rafaelslist.com. It's actually not every single question, but rather all the questions that I have felt are top quality questions. Good questions for you to practice on. You can keep track of your progress here. You can even filter by different topics just to make it a little bit easier for you. So I hope that you find this beneficial. Hope that it's really fun for you all. And looking forward to coding along with you all again tomorrow at 5 p.m. Eastern. Thank you.